Hello friends, welcome to BSS Studies. I am Bala. Yesterday we have completed Newton's first law, and today our topic linear momentum. Linear momentum. Here, what is linear momentum? The quantity possessed by a moving body. Here, linear momentum means the quantity possessed by a moving body. Here, the quantity means mass. Quantity means mass. The mass possessed by a moving body. Here, moving body means it has a v velocity, some v velocity. Here, some v velocity is there. Velocity. Here, the mass possessed by a moving body traveling with a v velocity. If we multiply mass and velocity, here, if we multiply mass and velocity, we can get linear momentum. Here, the quantity possessed by a moving body means mass into velocity. Okay, here the quantity means mass, and moving body have v velocity. Then we have to multiply mass into velocity. Then we can get linear momentum. Okay. The quantity. Here quantity means mass possessed by a moving body. Moving body have v velocity. If we multiply mass into velocity, we can get momentum. Here linear momentum symbol is P. Okay. Here P bar, because it is a vector. How it is formed? P bar is equals to mass means scalar m, and velocity means vector v bar into v bar. Here mass into velocity means scalar into vector. So P bar is a vector, linear momentum. Here mass is scalar, velocity is vector. Scalar into vector. Here scalar into vector is equals to vector. We are multiplying mass into velocity, then scalar into vector. So linear momentum is a vector quantity. It is a vector quantity. Okay. Here the quantity possessed by a moving body means we have to multiply mass into velocity. Quantity possessed by a, by means multiplying. Here we are multiplying mass into velocity. Product of mass into velocity. This is a statement. In other ways, the product of mass and velocity. This is simple definition. The product of mass and velocity. Here we are using the quantity possessed by a moving body, and this is the simple statement, the product of mass and velocity. Here we are multiplying mass and velocity. The simple statement, we are using product. Okay. Here velocity have a direction, because vector have both magnitude and direction. So velocity have specific direction. So scalar into vector means vector known. Here this direction will get momentum also. Here another important point, direction of momentum is same as direction of velocity, because in this mass is a scalar. It has no direction. So velocity has direction. So this direction will get momentum. For example, I am taking the direction of velocity v bar is in north. I am taking, for example, the direction of velocity is in north. We are multiplying mass into north. Then we will get direction of momentum north only. We are multiplying scalar into vector. So this direction only remains. Okay? Because this mass do not have specific direction. Okay? This is the linear momentum. Units. In this SI unit of linear momentum means, here linear momentum is P bar is equals to mv bar, mass into velocity. Here mass SI unit is kg. Here velocity SI unit is meter per second. Here mass SI unit kg. SI unit of velocity meter per second. Kg meter per second is the SI unit. And CGS. CGS unit of mass. Gram. CGS unit of velocity. Centimeter per second. This is the CGS unit. Okay? These are the units. So change in momentum. Change in momentum. Change in momentum means delta P bar means change in momentum. Here we have to use U bar and V bar. U bar means initial velocity, V bar means final velocity. Here change in momentum means delta P bar. Here delta P bar represents final momentum minus initial momentum. Delta P bar represents final momentum minus initial momentum. Okay? Here velocity, this is final velocity, this is initial velocity. So here initial momentum is mu bar, because this is initial velocity, and final momentum is mv bar. Okay? So delta P bar is final momentum minus initial momentum. So this is final momentum and this is initial momentum. We have to subtract. So mv bar minus mu bar. So we have to take common as mass. So v bar minus u bar. Okay? This is the delta P. Okay? This is change in momentum. Here change in momentum, we have to use initial velocity, final velocity, and delta P bar means change in momentum. This delta P bar represents final momentum minus initial momentum. So here initial momentum mu bar, because this is initial velocity. Here final momentum mv bar. We have to subtract. We can get change in momentum by subtracting final momentum minus initial momentum. Okay? So here delta P bar is equals to mv bar minus mu bar. This is the change in momentum. In this, initial velocity is 0. if initial velocity is 0, then change in momentum is mv bar. If initial velocity is 0, change in momentum is mv bar. If final velocity is 0, delta p bar is minus mu bar. This is from starting to rest. So initial velocity is 0. So delta p bar is mv bar. It comes to rest, which means final velocity is 0. So delta p bar is minus mu bar, because this becomes 0. 0 minus mu bar means minus mu bar. Okay. So this is linear momentum topic. Newton's second law. In this Newton's second law, rate of change of momentum is equals to force. In this second law, it states that rate of change of momentum is equals to force, which means here rate of change of momentum means change of momentum means mv bar minus mu bar. Rate means by time. Okay. Here rate of change of momentum means mv bar minus mu bar by time. Here rate means per time, per unit time. Okay. So here mv bar minus mu bar by time means we have to take common mass. So mv bar minus u bar by time. Okay. So here mass, here v bar minus u bar by t means acceleration. Here a bar is equals to v bar minus u bar by time. So here this is acceleration. So ma bar. This is force. Mathematical formula of force. ma bar. Mass into acceleration. Okay. This is the Newton's second law. It states that rate of change of momentum is equals to force. This is mv bar minus mu bar by time. Rate of change of momentum means mv bar minus mu bar by time. Here we taken m as common, and here v bar minus u bar by time means acceleration. So mass into acceleration is force. Mathematical formula. Okay. We have to derive F is equals to ma. Force is equals to mass into acceleration. Here mass into acceleration means scalar into vector. Here this is scalar, this is vector. Scalar into vector. So force is a vector quantity. Force is a vector quantity. Force is a vector quantity. In this, A has specific direction and mass does not have specific direction. So this direction will get force. We already know P bar is equals to mv bar. In this direction will get momentum. In this formula, acceleration's direction will get force. Okay. So here we have to derive force is equals to mass into acceleration. Okay. I am taking this is a surface and one object is there. I am applied some force on this direction. and acceleration is in this direction. Acceleration is in this direction. So force is directly proportional to mass when acceleration is constant. In any position, if acceleration is constant, then force is directly proportional to mass. Force is directly proportional to acceleration when mass is constant. When mass is constant, force is directly proportional to acceleration. When acceleration is constant, force is directly proportional to mass. Okay? I am taking this as first equation and this as second equation. Okay? From these equations, from 1 and 2, force is directly proportional to MA, because this is equal, so MA is directly proportional to force. So force is equals to K MA. Here K is a proportionality constant, so this is K is equals to 1. Okay, so here force is equals to MA. We have proved that force is equals to mass into acceleration. Okay. Units of force. Units. Here units. Here force is equals to MA, mass into acceleration. In this SI unit is, here SI unit of mass kg, and SI unit of acceleration meter per second square. Here SI unit of mass kg, SI unit of acceleration meter per second square. This is the SI unit of force. This is written as Newton, N Newton. Okay, this is the unit. Newton itself, they gave his name, Newton. This is the Newton. And CG's unit of mass gram, and acceleration centimeter per second square. So the name of this unit is dyne. The name of this unit is dyne. The name of SI unit is Newton. Okay. So the relation between Newton and dyne. 1 Newton is equals to dash dyne. So here 1 kg meter per second square. Here 1 Newton means 1 kg meter per second square. Here 1 kg means 1000 grams. 1000 grams. And here 1 meter means 100 centimeter per second square. Here second square are equal. No change. So here 1 kg means 1000 grams. 1 meter means 100 centimeter square. So here 1000 into 100 gram per centimeter square. So here 1 kg meter per second square is equals to, here 1 lakh. 1 lakh means 10 to the power of 5. 5 zeros are there. So 1 kg meter per second square is equals to 10 to the power of 5 gram per centimeter per second square. This is the relation. 1 Newton is equals to 10 to the power of 5 dyne. Okay. So today's topic is completed. మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్